So now let's look to see how we would use Excel to do a multiple regression model. Again, the point of the main goal with 501 is that we're able to interpret a regression output table like the one that Excel will give us or the one we see in a journal article, but not necessarily that we do it ourselves. But I do think it's important just to have seen it at least once, just so you know where all these pieces of information come from. So as we talked about in the lecture, we can use multiple predictors in a regression model. It's called a multiple regression model. So again, we are looking at the association between the high temperature that day in Phoenix, Arizona, whether or not it rained, and what day of the week it was, or whether or not it was a weekend. Between those three variables and the number of heat-related emergency department visits that took place in Phoenix that day. So again, as we discussed in the lecture, there are some things that we'll have to do in order to get this data ready for regression. So temperature, we'll start with heat-related ED visits. Heat-related ED visits is a continuous variable, so linear regression will work for us, assuming a lot of assumptions are met. Temperature is a continuous variable, so we don't have to do anything with that. Again, assuming that we've met a fair number of assumptions and that we've checked for data outliers, such as this day in July that we had to address in the previous video. Precipitation, it looks like we have it coded here as yes, no. It could also be a continuous variable where maybe it's the precipitation in inches. But what we're interested in is just a very crude measure, yes or no, did it rain that day? Unfortunately, regression models don't understand what yes and no means, which means we have to put it in a language it does understand. Again, we can use recode yes and no into ones and zeros, and I'll show us how to do that in a second here. Likewise, with day of week, we're actually the underlying thing we're interested in is whether or not it's a weekend. We can do that a couple of different ways, but the good news is I actually have it all prepared for us here. We have zeros and ones here and zeros and ones here. I got there by using some formulas and coding. So just very quickly, in order to turn this into a 0 and 1 variable, I use an if statement. If this cell equals yes, and notice you have to put it in quotes, then return a 1. If it doesn't, return a 0. There are some things you have to watch out for here. If your data set had yes, no, and unknown, you'd have to think about how you want unknown to show up there. Or if some were blank, you have to be careful because everything that isn't a yes in this formula will be coded as 0. I know that actually that's going to work fine for us in this point, so we can just fill this all down. Here we see that yes, it rained on July 10th, and so we have a 1 over here. It didn't rain any of these days, so we have zeros over there. And again, for people who aren't familiar with Phoenix, this might make less sense for other areas of the country where it rains a little bit more often than it does in Phoenix, but you will know if it's raining in Phoenix because it rains a lot. It rains, go for weeks at a time without rain, and then we'll get a huge amount of rain one day. We can do the same thing with day of the week, where we use if coding. But actually another thing that's fairly easy to do, you just got to be a little bit careful, is to just manually code here. So this is an entire week, and we can see here that I put in no, it's not a weekend, Monday through Friday, and that yes, it is a weekend, Saturday and Sunday. Excel will actually copy this whole pattern all the way down the page if we want it to. You have to press copy and then paste just like this. Let's move on though, because we already have a lot to do on this next screen. So you can see here I have all the data completely ready to go. I have our temperature, our precipitation, and our weekend variables all loaded in. So let's do the regression. And here our Y variable is still exactly the same, heat-related ED visits. And now our X range is no longer an X variable, but X variables. So it's all three of these. So you'll notice you have to have your data arranged so that you can just highlight one area that have all of the x variables. You can't have x variables sort of scattered across the spreadsheet. I did include labels in there. Let's keep the confidence level there. And that output cell looks fine to me. So what do we see here? Let's look at what we actually have. And again, you don't need to do this. I just find it a little bit easier to have this formatted approximately the same way. So again, we can see that we have 92 observations. Our overall R square for the model or the, is 0.26. So that means we've explained 26% of the variation in our outcome variable or heat-related ED visits. We also, I didn't ask for this, but it did a ANOVA. We aren't covering that in HCD 501, so we can just more or less skip right down here to the regression output table. And this looks looking like what you will have seen in the lecture this week. We can see here that there is a significant association between some of the variables, but not with other variables. So there's a significant association between temperature and heat-related ED visits. We can interpret the relationship in that for every increase, every 1 unit increase in temperature or every 1 degree increase in temperature, there is that's associated with a 2.409 increase in the number of heat-related ED visits to all Phoenix hospitals that day. The relationship between precipitation and heat-related ED visits is not significant, but we can see that there is a negative coefficient with that in front of that, a negative sign in front of that coefficient, which means that if it was a significant association, it would be significantly negatively associated, or an increase in precipitation variable is associated with a decrease in heat-related ED visits. Likewise, with weekend, it's negative but not significant. But again, since these are dichotomous or dummy variables, we don't interpret it by saying a 1 unit increase in weekend is associated with a negative 0.196 unit decrease in heat-related ED visits. We just say, remembering that a 1 unit increase in weekend would be the same as going from 0 to 1. So it's the same as saying, compared to when weekend equals 0 or when it's not the weekend, when weekend equals 1 or when it is the weekend, there are an average of 0.196 fewer heat-related ED visits. Same thing with precipitation. Compared to when it isn't raining or as precipitation equals 0, precipitation equals 1 or when it is raining, there are an average of 3.341 fewer heat-related ED visits. If that relationship is causal and assuming it was significant, which is not here. But because we know all of these things, we can actually plug all these numbers into our formula to determine what the expected number of heat-related ED visits would be if the temperature was going to be, say, 115 and we didn't expect it to rain and it was the weekend. One thing you'll note again here is this coefficient for the intercept is negative. So that means if temperature was 0, we would expect negative 137 heat-related ED visits. Again, not plausible to have less than 0, and also not necessarily relevant given that the temperature, 1, it's never going to be 0, but also we would never want to predict the number of heat-related ED visits when the temperature is 0. We may want to predict the number of cold-related ED visits, but that would be a separate model. So one caveat here is if I were to ask you, just like it wouldn't make sense to predict for the value of 0, it wouldn't make any sense to predict for the value where the temperature is, say, 700 or 7,000 or 7 million degrees. Really what we can use these regression models for is predicting right in this range, this sort of 100 to 120 degree range, whether or not there's precip and whether or not it's a weekend. That's what regression is helpful for, and it's what we are going to be using it for in this course.